Hello friends, in this video we'll be discussing kuhn-tucker method from NLPP, two variables and two constraints. Welcome back friends. Let us move on and let us discuss kuhn-tucker problem, but now there will be two variables and two inequality constraint. Inequality is must, as discussed number of times. If it is equality, then the problem will belongs to Lagrange's. So let us move on. Here there are two variables and two inequality constraints, and this is the given problem. First of all, let us write it down the conditions. What are the conditions? The first condition is dou L upon dou x1 equal to 0, dou L upon dou x2 equal to 0. Condition number 3, this we have already covered in the last videos. The third condition is lambda 1 times the first constraint equal to 0. Next, lambda 2 times second constraint equal to 0. Constraint less than equal to 0. Second constraint less than equal to 0. And finally, x1, x2 greater than equal to 0. Lambda 1, lambda 2 depends. In the problem, it is maximized. See here. Therefore, it will be greater than equal to 0. This is equation number 7. So, these are the conditions if the problem is of two variables and two inequality constraint. So, let us start solving. First of all, we need to form L here. So, what is L? L will be a function of x1, x2, and then there are two constraints. Therefore, from the first constraint we'll get lambda 1 and then lambda 2. So that will be objective function minus constraint. So objective function is 10x1, 10x2 minus x1 square minus x2 square minus lambda times constraint. Now here we have two lambdas. So lambda 1 times first constraint. So what is the first constraint? First constraint is this. 8 will come to this side, and x1 plus x2 minus 8 minus lambda 2 times. See, in the last problem there was only one constraint, therefore we wrote minus lambda times constraint, but here there are two constraints, therefore it will be minus lambda 1 times and minus lambda 2 times, where the first constraint h1 is equal to 8 will come to this side, x1 plus x2 minus 8, and h2 is equal to 5 will come to this side, minus x1 plus x2 minus 5. So we got L. Now we gonna write it down the 7 conditions based on this. So let us start. The first is dou L upon dou x1 equal to 0. So from this we gonna differentiate L with respect to x1. So this will be 10, this will be 0, from this minus 2x1, this will be 0, from this you will get minus lambda 1, because with x1 we have lambda 1, these two are constants 0, and from this minus minus plus lambda 2. If lambda 2 is multiplied to this is constant, derivative 0, again this is 0, so this will be equal to 0. This is equation number 1. Next, see here. The next condition is dou L upon dou x2 equal to 0. Dou L upon dou x2 equal to 0. Let us differentiate this L with respect to x2. So this will be 10 minus 2x2 minus lambda 1 x2, so that is minus lambda 1 if you differentiate with respect to x1, and here it will be minus lambda 2. How minus lambda 2? This minus lambda 2 in plus x2, so that will become minus lambda 2 equal to 0. This is equation number 2. What next? See here, lambda 1 times constraint equal to 0. So here it will be lambda 1 times the first constraint, that is h1. This is equation number 3, and lambda 2 times second constraint h2, and h2 here is this. See this, minus x1 plus x2 minus 5 equal to 0. This is equation number 4. Next, constraint less than equal to 0, 5, and second constraint less than equal to 6. So first constraint is this, that is x1 plus x2 minus 8 less than equal to 0. This is 5. This is my second constraint, minus x1 plus x2 minus 5 less than equal to 0. This is 6. And finally, x1, x2 greater than equal to 0. And since the problem of maximized type, therefore, lambda 1, lambda 2 greater than equal to 0. Suppose the problem would be minimized, then here to be less than equal to. So these are the 7 conditions if the problem is of 2 variables and 2 inequality constraints. Let us move on and let us solve the problem further. Remember the last problem that we solved? In last problem there was only one lambda. I am talking about 2 variables and 1 inequality constraint. There was only one lambda, therefore there were only 2 cases, lambda equal to 0, lambda not equal to 0. But here problem is there are 4 lambdas. See here, lambda 1, lambda 2, lambda 1 and lambda 2. Here there are 2 lambdas. Therefore there will be 4 cases. It is fixed. In the last type, 2 variables and 1 inequality constraint, 2 cases only one lambda, so it can be 0 or it will not be 0. Here there are 2 lambdas, so always fixed there will be 4 cases. So let me write it down, 4 cases. Case number 1, lambda 1 equal to 0, lambda 2 equal to 0. Yes, please tell me what will be the case number 2. Case number 2, lambda 1 equal to 0, lambda 2 not equal to 0. Next, case number 3, opposite to this. Here lambda 1 is 0, lambda 2 is not 0. Here lambda 1 will not be 0 and lambda 2 will be 0. And what will be the last case? Yes, please tell me. Both are non-zero. If the problem is of 2 variables and 2 inequality constraint, it is a fixed. There will be 4 cases in all the problems. Now we're gonna solve for all the 4 cases to get the solution. One thing must be clear in our mind that, see, in the last 2 variables, 1 inequality constraint, 1, 2, 3 is used for calculation, 4 and 5 used for checking. So here 1, 2, 3, but 3 and 4 are C equivalent. So 1, 2, 3 and 4 will be used for calculation and 5, 6 and 7 will be used for the checking. So which calculation? Basically I want to get the value of x1 and x2. If I'll get the value of x1 and x2, I'll put here in this equation and I'll get the value of z. For getting the value of x1 and x2, I'll be using equation number 1, 2 and 3 and 4 to get the value of x1 and x2. Once I get the value, then I'm going to verify whether the value x1, x2 satisfying equation number 5, 6 and 7 or not. If x1, x2 satisfies 5, 6 and 7, then I'm going to put in z and I'm going to get the final result. Let us start. The procedure will exactly remain same. Lambda 1 equal to 0, lambda 2 equal to 0. Remember the last problem? Let's try to compare both the problems. What we did when lambda, in that case lambda was 0, lambda equal to 0, then we substituted in equation number 1 and 2. Here also we're gonna do the same thing. See here, my aim is to, what is my aim? My aim is to get the value of x1 and x2, that's it. So if you compare, if you observe these 2 equations, 1 and 2, we cannot solve these 2 equations. Why? Because there are 2 equations and 4 unknowns. There are 2 equations and 4 unknowns. What are the 4 unknowns? x1, x2, lambda 1, lambda 2. Therefore, and if lambda 1 equal to 0, lambda 2 equal to 0, if I'm going to put in 1 and 2, let us put in 1 and 2, see this will be 0. What I'll get? 10 minus 2x1 equal to 0 and 10 minus 2x1 equal to 0 because these 2 values are 0. These 2 values 0 means 10 minus 2x2 is equal to 0. x1 is equal to 5, x2 is equal to 5. x1, x2 both the values are 5. We got the values, but I need to check whether these values satisfies equation number 5, 6 or 7 or not. So let us check. Let us put these values in equation number 5. See here, if I'll put x1 and x2 5, 5, so 5 plus 5 10, 10 minus 8 is 2. 2 less than equal to 0. 2 is not less than equal to 0. That means equation number 5 is not satisfied. Since equation 5 not satisfied, therefore reject. Since equation number 5 is not satisfied, we gonna reject this pair. Suppose 5, 6 and 7 all are satisfied. This is my solution. I'm going to put in the value of z and I'm going to get the value of z. But here equation 5 is not satisfied, therefore reject this pair. Let's move on and let's find the let's solve the case number 2. See here, lambda 1 equal to 0. Let us put in 1 and 2. Lambda 1 equal to 0. Let us put in equation number 1 and 2. I'll get 10 minus 2x1. See here, 10 minus 2x1. Lambda 1 we have taken 0. So this is 0 plus lambda 2 equal to 0. And if I'll put lambda 1 equal to 0 in equation number 2, it will be 10 minus 2x2 minus lambda 2 equal to 0. What next? Lambda 2 not equal to 0. Now see, from equation number 4, lambda 2 not equal to 0. See here, lambda 2 is not equal to 0. What does this mean? In equation number 4, it means either lambda 2 is 0 or this particular equation is 0. It's clearly given lambda 2 is not 0. See, one has to be 0, so that this resultant multiplication will be 0. So it is given in the problem, given in the condition, lambda 2 is not 0. Since lambda 2 is not 0, this has to be 0. From 4, lambda 2 not 0, this has to be 0. Solve these three equations and we'll get the value of x1, x2 and lambda. x1 is 2.5. This values you will get in Calc, so you can use Calc to get the values. x1 we got it as 2.5 and x2 we got it as 7.5. Let us first check whether these values satisfying equation number 5, 6 and 7 or not to accept or reject these values. So let us put in equation number 5. See here, this is 2.5, 7.5. Again this will become 10. 10 minus 8 less than equal to 2. 10 minus 8 is 2. 2 is less than equal to 0. No. Equation 5 not satisfied. Reject. See, the procedure is similar. There also the procedure was same. See, if lambda equal to 0, remember the last problem, if lambda is equal to 0, we gonna put in equation number 1 and 2 in the last type. And if lambda is not equal to 0, we'll get equation from, we used to get equation from third. The same procedure here. See, if it is 0, we're going to put in 1 and 2. If it is not 0, we're going to get equation from 3 and 4. See here, both are 0. We substituted in 1 and 2. We got equation from 1 and 2. This is 0. So we substituted in 1 and 2. This is not 0. If it is not 0, then we're going to get from 3 or 4. The procedure is same. Let us move on and let us solve the third case. Now please tell me, lambda 1 not equal to 0. What does this mean? From where we're going to get the equation? See here, lambda 1 is not equal to 0. What does this equation mean? This equation means either lambda 1 is 0 or this particular equation is 0. It's clearly given in the problem that lambda 1 is not 0. So if lambda 1 is not 0, what does this indicate? This particular equation is 0. That is from 3, x1 plus x2 minus 8 equal to 0. Next, lambda 2 equal to 0. Then lambda 2 equal to 0, I am going to put in equation number 1 and 2. If I'll put in equation number 1 and 2, lambda 2 equal to 0, this I am going to get 10 minus 2x1 minus lambda 1 equal to 0 and 10 minus 2x2 minus lambda 1 equal to 0. I need to solve these three equations. If I'll solve these three equations, I will get x1 is equal to 4. This you will get it in calci, don't worry. And lambda 1 is equal to 10. So these values we got it from calculator. Now before accepting or rejecting these values, let us check whether they satisfy 5, 6 and 7 or not. So let us put in equation number 5. See here, x1 and x2 both the values are 4. So this is 4 plus 4 minus 8. That is 8 minus 8 less than equal to 0. 0 less than equal to 0. 5 satisfied. What about 6? x1 is 4 and x2 is also 4. So minus 4 plus 4 will become 0. Minus 5 less than equal to 0. 6 also satisfied. 5 and 6 satisfied. Let us check whether 7 is satisfied or not. See here, x1 is 4 and x2 is 4. So minus 4 plus 4 will be cancelled. Minus 5 less than equal to 0. Satisfied. Let us check for 7. x1, x2 greater than equal to 0. See here, they are greater than equal to 0. Lambda 1, lambda 2 both are also greater than equal to 0. See, lambda 1 is 10 and lambda 2 equal to 0. So these two values are also greater than equal to. Here equal to is also there. That means 0 will also do. That means 5, 6 and 7 satisfied. All the conditions are satisfied. Therefore we gonna accept this pair, and x1, x2 is my solution that I'm going to put in Z here, and I'm going to get the value of Z max. So put x1 is equal to 4 and x2 is equal to 4 here, and you will get the value of Z max as 48. Again you will get it in calculator. See, we got solution. You will get solution in only one case, but still we got the solution in third case also. We need to solve the fourth one also. Always solve all the cases. Let us move on and let us solve case number 4. See here, lambda 1 not equal to 0. So from equation number 3, if lambda 1 is not 0, this is equal to 0. From 3, x1 plus x2 minus 8 equal to 0. From 4, lambda 2 not equal to 0. See here, lambda 2 not equal to 0 means this has to be 0. Minus x1 plus x2 minus 5 equal to 0. If you solve these two equations, we'll get the value of x1 as 1.5, x2 as 6.5. Let us check whether 5, 6 getting satisfied or not. x1 is 1.5, x2 is 6.5. So 1.5 plus 6.5 means 8. 8 minus 8 less than equal to 0. 0 less than equal to 0. 5 satisfied. Let us check here. This is 1.5, x2 is 6.5. So this is minus 1.5 and minus 5. That means minus 6.5 plus 6.5. That is 0. 0 less than equal to 0. Satisfied. 5 and 6 satisfied. Equation number 5 and 6 satisfied. Just wait. It's not yet done. 7. We need to check for 7. For checking 7 equation, x1 and x2 should be greater than equal to 0. Satisfied. Finally, we gonna check for lambda 1 and lambda 2. One of the lambda values will be negative. Let us check. Let us check for lambda 1 and lambda 2. How you can find lambda 1 and lambda 2? From where? See, it's very simple. Put x1 and x2 in equation number 1 and 2. If you put x1 and x2 in equation number 1 and 2, x1 value is 1.5. So see here, if I'll put in equation number 1 x1, that is 1.5. So this will be 2 into 1.5, that is 3. 10 minus 3 is 7. 7 will go to that side and will become minus 7. Minus lambda 1 plus lambda 2 equal to minus 7. So this is one equation. if I'll put x2 6.5 here, this will become 13. 10 minus 13 is minus 3. We'll go to that side, will become plus 3. So this is minus lambda 1 minus lambda 2 equal to 3. If you solve these two equations in calculator, you will get lambda 1 as 2 and lambda 2 as minus 5. You check, you'll get the values. Suppose there is some mistake in the calculation, you can rectify yourself. So silly mistake can happen. So lambda 1 equal to 2 and lambda 2 equal to minus 5. So these are the two values of lambda that we got. It clearly indicates equation 7 not satisfied. Why? Because for equation number 7, lambda 1 and lambda 2 must be greater than equal to 0. Not satisfied, reject. So this pair will also be rejected. This pair will be rejected, this pair will be rejected only when one pair is accepted, and this is your final solution for Z max is equal to 48. We're done with the problem. Hope you understood. I highly recommend watch these videos for 2 times, 3 times, 4 times till the time all the steps are clear in your mind, because the procedure is same. You solve one problem or 10 problems of the same type, the procedure is exactly similar. So in the next video, if you have still doubt, don't worry. In the next video also we'll be discussing one more example of the same type. Thank you.